we will discuss about drift velocity and mobility of charge carrier. Suppose this is a conductor or semiconductor. Each conductor or semiconductor is made up with several number of atoms which are arranged in a specific manner. This arrangement of atom is called lattice structure or lattice structure or crystal structure. Crystal structure. So each crystal structure contains several number of atoms. Now each atoms contain several number of electrons. Now the outermost electrons of the atoms are loosely bound to the nucleus. That's why these outermost electrons may get free from nucleus and they can move through the crystal of this matter, that means conductor or semiconductor. That means this electron, the electron which are going through or which are going through the crystal structure is called free electrons. So the electrons which are free from the nucleus of the atom is called free electrons, and this electron can move through the crystal of this crystal structure of the semiconductor or conductor. In conductor, only free electrons are present as a charge carrier. Now in case of semiconductor, there are two types of charge carrier. One is free electrons and another is holes. Both the charge carrier carry current. Now suppose this is a semiconductor and this is a conductor. Both have several number of free electrons at room temperature, but these two, conductor and semiconductor, cannot carry current at normal temperature without any electric field, because the movement of these free electrons or holes in a semiconductor are random. That's why the net current at conductor is 0 and the net current at semiconductor also 0 because of the random movement of the charge carrier. Okay. Now if I apply a voltage across this conductor, now an electric field will develop across this conductor. Then the charge carrier inside this semiconductor will get force, electrostatic force. So what will be the electrostatic force? So electrostatic force of charge Q will be Q into E. E is the electric field across this conductor. Now this charge carrier get electrostatic field, electrostatic force, then it will move in a specific direction. So this is negative charge, that's why the movement of this electron will along this direction opposite to electric field. Because of the electrostatic field force, this charge will move opposite to electric field. The velocity of this charge carrier will increase because of the acceleration of this semiconductor. This is the mass of the electron, and suppose the acceleration of electron is a, so it will be q into e. So acceleration is q into e divided by m. So every charge carrier get accelerated due to electric field. So due to this acceleration, the velocity of this charge carrier will increase indefinitely with time. So velocity will increase infinite as time will increase. Now what happens when this charge carrier will move through this semiconductor crystal structure? They will collide with the ions. That means the charge carrier will collide with the ions. For this collision, charge carrier will lose their energy. After several collision, the charge carrier will attain a maximum fixed velocity Vd. So this is the fixed speed, fixed velocity when this charge carrier attain fixed velocity. Okay, now suppose this is the two atoms and this atom collide with this ion. The time between this collision is tau. So the velocity at this condition is Vd is equals to a into tau, because suppose the a into tau. So if I put this value a, so it will be q into e divided by m into tau. It can be written as q tau divided by m into e. Suppose for electrons, the mean free time between two collision tau, q and m, both three terms are constant. That's why you can write that Vd proportional to E. The constant mu can be written is equals to mu E. Mu can be written as q tau by m. So this mu is called mobility. Okay, so we have gotten two terms. One is, this is Vd. This Vd is called drift velocity. What is the drift velocity? Drift velocity is the maximum velocity under electric field which the charge carrier attain. And what will be the mobility? So mobility can be written as mu equals to Vd divided by E. So you can define mobility as the drift velocity per unit electric field. What is the mobility? So mobility of A charge carrier is defined as the drift velocity per unit electric field. Now, semiconductor contain two types of charge carrier. So that's why there are two types of mobility. One is the mobility of hole and one is mobility of electrons. So mobility of hole can be written as charge of the hole into tau divided by m of h. So what is the m of h? M of h is the effective mass of hole, and the mobility of electron, the charge of electron divided into tau divided by mh. This tau for hole and this tau for electrons is equals to, here the me, this is must be me. So me is the effective mass of electrons. This is the, what is the drift velocity and mobility of free electrons and free holes. Now, if I want to calculate the unit of mobility, it will be like this. So mobility is given by Vd divided by E. So unit will be, Vd is the velocity, that means this will be meter per second. This is electric field, so it will be volt per meter. So it can be meter per second multiplied by meter by volt. So it will be meter square divided by volt second. This is the unit of mobility. Now I will discuss what is the dependency term of mobility. So mobility depends with several number of parameters. So now I will discuss about dependency of mobility. We have gotten that mu equals to Vd divided by E. This is mobility equals to drift velocity divided by electric field. So this mobility must depend of electric field. So number one, it's depend on electric field. Suppose if I increase this potential difference, then the electric field will increase. So when the value of electric field less than 10 to the power kilovolt per semi, then the mobility is equals to constant. So mobility cannot change when the electric field less than 10 to the power 3 kilovolt per semi. Volt per semi, not kilovolt. This is volt per semi. Okay. When this electric field is greater than 10 to the power 3, less than 10 to the power 4 volt per semi, then mu equals to 1 by root over E. When electric field is greater than 10 to the power 4 volt per semi, then mu equals to 1 by E. That means proportional to, this is equals to not, this is suppose constant, this can be written as proportional. Okay, you can written this. So from this equation we can write that V equals to Vd by E. So from this data we can say that drift velocity is defined for high electric field. So drift velocity is the maximum velocity which is attained by this charge carrier of the of conductor or semiconductor. So Vd is the maximum velocity which can attain a charge carrier under electric field. So this is the drift velocity. This is the how mobility depends on electric field. Now number 2, temperature. Temperature. How mobility depends on temperature. Two facts will rise to describe the dependency of mobility on temperature. What is the fact? Number 1 is the lattice scattering. Lattice scattering. Number 2 is impurity scatterings. What is this lattice scattering? When the temperature, suppose this is a atom, this is a atom, this is a atom, and this is a atom. Suppose this is a crystal structure of a conductor. If I increase temperature, then the vibration of this atom and vibration of this atom, all the atom will vibrate with more energy. Okay, so if I increase the temperature of this crystal, then the vibration of each atom will increase. Then the collision will increase. The collision will increase. If the charge carrier collide more and more with the ions, then the velocity of this collision of this charge carrier will decrease. If velocity of charge carrier is decreased, then the mobility of charge carrier will also decrease. So if I draw this is temperature, this is mu. So at high temperature, this is high temperature, high temperature, the mobility will decrease with temperature at T to the power 3/2. This is for lattice scattering, and lattice scattering will occur at high temperature. Okay, so what happen when you increase the temperature of the metal or semiconductor? The vibration of this atom will increase. That's why the number of collision between the charge carrier and the ions will increase. That's why the velocity of the charge carrier is decreased, and if the velocity of the charge carrier is decreased, then the mobility of the charge carrier is decreased. Okay, so this will happen for high temperature. What is the impurity scattering? Impurity scattering is happening when the temperature is low. Temperature is low, that means the momentum of the charge carrier and the interaction with two ions, so momentum of the charge carrier is less than the interaction of ions. That's why when temperature is low, then the interaction between two ions is more then the momentum of the electrons or charge carrier. That's why the mobility will also decrease when the temperature is decreased. So this is T to the power 3 by 2. This is for impurity scattering. So in mobility is depend upon temperature. How the value of this mobility with this temperature is varying. Number one, for silicon and for germanium. So mobility mu proportional to T to the power m, suppose m. So m can be vary on the type of semiconductor, number one silicon and number two germanium. So it has both, this is for hole and this is for electrons. So for hole, the m will be m for holes, the m for holes, for m for holes, m for electrons is given by 2 to the power, this is for silicon. So for silicon the m is 2.5 for electrons, and for holes it is 2.7. Okay. For germanium, m for hole and m for electrons. For holes it will be 2.33. This is 2.33 and it will be 1.7666. Okay. So mobility depends on temperature by this equation, when for the silicon the value of m for hole it will be 2.7 and value for m for electrons it will be 2.5. For germanium it will be 2.33 and electrons 1.33. So this is the second, how mobility is depend on temperature. Number 3, types of materials. So if I take silicon and if I take germanium, then the mobility will differ from each with another. So for silicon and for germanium, the mu of germanium greater than the mu of silicon. Okay. So for germanium the mobility is greater than the mobility of silicon. Number 4, the charge carrier. If we have two charge carrier, one is electron, one is hole. Okay, one is electron and one is hole. Always electrons has more mobility is more. For the electron mobility is more than the holes. Okay, this is the dependency of mobility upon material, charge carrier, electric field and temperature. If I take one problem from this theoretical part, we can say that the problem is suppose a semiconductor. The mobility of semiconductor, suppose electron mobility and hole mobility. The mobility of electrons and mobility of holes are given as 0.39 and 0.19 meter square per volt second. This is meter square per volt second. If I apply electric field of 10 to the power 4 kilovolt per meter, then what will be the drift velocity of electrons and drift velocity for hole? So drift velocity is given by mu into E. So for electron this is mu E. So it will be 0.39 into 10 to the power 24. So this is kilovolt, kilo. So it will be 3.9 into 10 to the power 3. So it will be 3.9 kilometer per second. With same formula we can write that this is 0.19 into 10 to the power 4. So it will be 1.9 kilometer per second. So in this way you can solve the problem.